Hi, in this video, we are going to continue the series on vectors. Today, we are going to do some problems that will help us revise what we have learned so far, right? So let's start with the first problem. The question says, find the vector equation of a line passing through the points I plus j plus k and I minus j plus k. So the vector equation of a line passing through the points, you have to basically figure out the general vector for a point on this line. And the best way to do it is to think of section formula. So if it is point P here and point Q here, any point on the line R can be written as 1 minus T P vector plus T times Q vector. Basically, we are saying it is being divided in the ratio T is to 1 minus T, the segment, and T belongs to real, right? So here R, P, and Q are position vectors of these points, P, R, and Q, right? So that is a good way to find the vector equation of a line passing through two given points. So therefore, we will do here, it is 1 minus T I plus j plus k plus t times I minus j plus k. And that's it. That will give you the equation of a line that passes through the line joining these 2 points, because this is a general point on the segment between these two divided in the ratio t is to 1 minus t, right? So remember this method. It's a very useful method to find the vector equation of a line through 2 points. Okay. The next one is question 2. If A, B, C are non-coplanar, find the point of intersection of the line passing through the points 2a plus 3b minus c, 2a plus 3b minus c, and 3a plus 4b minus 2c with the line joining the points a minus 2b plus c and a minus 6b plus 6c. So basically, think about it. Here, there are two lines given. One line is the one through these 2 points, and the other line is the one through these 2 points. And our question is asking us to find the point of intersection of these 2 lines, right? So first of all, in order to do point of intersection, I have to write vector equation of each line. Vector equation of line 1. That would be R is equal to, by the same method that we have learned, 1 minus T into 2A plus 3B minus C plus T times 3A plus 4B minus 2C, right? That is the equation of the first line. Similarly, vector equation of second line of L2 would be R is equal to 1 minus, now I'll use a different real number, 1 minus S A minus 2B plus C plus S times A minus 6B plus 6C. And here T and S are real numbers. Right. Now in this situation, we have to find the point of intersection of these two lines. So in order to do that, we have to solve the two line equations. So first I will write line 1 equation like this. R vector is equal to, what is the coefficient of A? It is 2 times 1 minus t plus 3t. So it will be 2 minus 2t plus 3t. So 2 plus t A cap plus 3 minus 3t and 4t. So 3 plus t B cap plus t minus 1 from here and minus 2t. So minus t minus 1 C cap. This is your line 1, and line 2 will be, R will be here 1 minus S plus S, right? So that would be A cap simply, minus 2 plus 2S minus 6S. So that will be minus 2 minus 4S B cap, and C will be 1 minus S plus 6S. So 1 plus 5S C. So this is your L1 and L2, and we have to solve this. So we have to find S and T which satisfy both. So by comparing coefficient, you will get 2 plus T is equal to 1. So that means T is equal to minus 1. And if T is minus 1, similarly, you can immediately find the point of intersection. Then if you get the value of T, you can find the point of intersection. That is A plus 2B and minus 1, so 1. So that's it, A plus 2B, right? A plus 2B is the point of intersection of these two lines. Notice how we have done it. We have written the vector equation of both the lines by section formula. And after that, we are doing intersection of these two line equations by comparing the coefficients of each vector, right? They must match because the point lies on both the vectors. Okay, so that is question number 2. Question 3 says, in a quadrilateral ABCD, if the midpoints of one pair of opposite sides, and the point of intersection of the diagonals, are collinear, then prove that the quadrilateral is a trapezium. Quadrilateral is a trapezium. So let's think about what this question says. There is some information given about the quadrilateral. What has been given is, this is a quadrilateral, let's say ABCD, right? Now, midpoint of one pair of opposite sides, let's say this is a midpoint N and this is a midpoint M, and N and M are collinear with the point of intersection of the diagonals. So if I draw the diagonals like this is the point of intersection of the diagonals, which is P. So apparently this is a straight line. We have been given that N, P, and M are on a straight line. And we have to prove that the quadrilateral is a trapezium, right? Quadrilateral ABCD is a trapezium. The way to prove that it is a trapezium, you have to prove probably that AD is parallel to BC, right? If you can show that AD is parallel to BC, then you will be done. Or you could also prove another pair of sides is parallel, right? So at least one pair of sides has to be parallel, right? Then only you can show that it is a trapezium, correct? So I don't know which pair of sides is parallel. This is still in doubt, but we have to show one pair of parallel opposite sides is parallel, right? Okay. So what we will do here is we'll try to use vector method. So we'll say A is the origin. A is the origin, and let's call AB as B vector. We are going to let AB be B vector, AC is C vector, and AD is D vector, right? And we are going to say M and N are midpoints of AB and CD, AB and CD. Therefore, you can easily say that AM vector will be B by 2, and similarly AN vector would be AD vector plus DC by 2, right? So AD plus AC right. So like actually AD vector is C vector, D vector, and AC vector is C vector. So, and this is the origin. So it is obvious that because this is the midpoint, AN should be by section formula, it should be C plus D by 2, right? We don't have to do this indirect method. Directly by section formula, the position vector of the midpoint should be what? It should be C plus D by 2, which is basically AD plus AC by 2, right? Okay. So we know AM vector and AN vector, right? Now let P be the intersection of AC and BD. The AC intersection BD. Now from here we can say that AP vector and AC vector are collinear. AP and AC are collinear because obviously they lie on the same line. So we can say AP is going to be T times AC, where T is some real number, and AC vector was C. So that gives us AP vector is equal to T times C vector, right? Okay. Now, similarly, M and P are collinear is given. So that means MP and MN are collinear vectors. So I will use that information now. M and P were collinear was given to us. So we will say that MP vector and MN vector are collinear. So we can say Mn is going to be some constant times MP, right? MP vector and Mn vector are collinear. So I can say Mn is equal to some constant S times MP vectors. So what is Mn? Mn is An minus Am. An vector minus Am vector is Mn. And that is equal to S times what is MP? That is AP minus AM, right? So S times AP minus AM vector. So this is coming from collinearity and the addition of vectors. So clearly we already know what AN is, right? AN was C plus D by 2. So putting all of that here, C plus D by 2 minus AM is B by 2, right? Is equal to S times, what is AP? We have already written AP as T times C. So T times C minus AM, which is B by 2, right? So what we are getting here is if you multiply everywhere by 2, you get C plus D minus B is equal to S into 2TC minus B. S into 2TC minus B, right? So from here, we are going to be able to rewrite this equation by bringing all the C and B on one side, right? So I'll do that on the next screen. I'm getting 2ST minus 1 times C plus 1 minus S times B vector is equal to D, right? Now, what we will say now, this result we have gotten, we can also say that let P divides the diagonal BD in the ratio of 1 is to K. So let me just draw the figure here roughly. This was the situation. This was N, M, this was A, B, C, D. And these were the diagonals. This was my P. So what I'm saying is, let's say P divides the side BD or diagonal BD in the ratio K is to 1 or 1 is to K. Then in that case, the AP vector, because AP is my origin, so position vector of P would become the ratio of 1 is to K here, right? So 1 is to K, let's say. So 1 time D plus K times B by K plus 1, right? So we are getting this is equal to KB plus D by K plus 1. That is your AP, but AP was equal to TC, as you remember. We had already done that, right? So from here we are getting another equation, KB plus D is equal to KTC plus TC. And if you rewrite it on one side, we can write it like this, KT, K plus 1 into TC, right? So KT plus T into C minus KB is equal to D, right? This is another equation that we are getting. And we had gotten another equation from here as well, from the fact that M and P were collinear, right? So from these two equations, you are getting the same thing here. So the vectors must be same. So we are getting equations now. 2ST minus 1 is equal to K plus 1 into T. And you also get 1 minus S is equal to minus of K, right? Okay. So if 1 minus S is minus of K, so we can replace the K. K is clearly S minus 1. And we can replace that in this equation here. You get S minus 1 plus 1. So ST is equal to 2ST minus 1, right? So that implies that ST is equal to 1. Correct? If ST is equal to 1, then notice here you are getting, put ST is equal to 1 in this equation, you get C plus 1 minus S into B is equal to D, right? So from here, what we get is C minus D is equal to S minus 1 into B, right? Okay. And C minus D is basically the position vector of the DC side. This is your DC side, C minus D is equal to some S minus 1 times B, and B is your AB side, right? So from here I am able to show that DC vector, the vector for this side is S minus 1 times AB vector, which means you are getting DC is parallel to AB. And if DC is parallel to AB, ABCD is a trapezium. Notice that my figure might look wrong, but that doesn't mean by analysis and solution is wrong. The figure, we did not know which two sides will be parallel, right? Here, by doing the proof, we have figured out that DC is coming parallel to AB. If M and P were lying on DC and AB and they were collinear, and this is what we did, right? We got two equations connecting B, C, and D. First equation was coming from MP and NP are collinear. Second equation comes from finding the point P in a different way by thinking of it as a point on the diagonal BD, which was being divided in the ratio 1:k, right? And then for the same point P, we are getting two different versions, so we can equate them. So we are basically saying that for D vector, we got two different equations. We equated that D vector. From there, we got that comparing coefficients gives us ST is equal to 1. And if ST is equal to 1, we were able to prove that DC is parallel to AB, right? So this is how we solve this problem using vector methods. Okay, let's go on to the next problem, question 4. If A is equal to I plus J plus K, B is equal to 4I plus 3J plus 4K, C is equal to I plus alpha J plus beta K. These are linearly dependent vectors. Linearly dependent vectors. And mod of C is equal to root 3. Find alpha and beta. So we have been given that A, B, C are linearly dependent. And if A, B, C are linearly dependent, then we can express any one in terms of the other two. Basically, that means that these three vectors are coplanar. So we should be able to write C as a linear combination of A and B. So here we can get scalars S and T such that C is equal to SA plus TB, right? So in that case, that implies C is equal to S times A is Si plus Sj plus Sk, and T times B is 4Ti plus 3Tj plus 4Tk. So we are getting I plus alpha A plus alpha J plus beta K cap is equal to S plus 4Ti plus S plus 3Tj plus S plus 4Tk cap, right? This relation is coming, which implies that S plus 4T is equal to 1. And we also know alpha is equal to S plus 3T and beta is equal to S plus 4T. So clearly beta will be 1. So we have already gotten the value of beta as 1. And we have this relation S plus 3T is equal to alpha. But we also have a third relation that 1 plus alpha square plus beta square, the modulus of C should be 3. We are getting alpha square plus beta square is equal to 2. Now, beta is 1, so alpha square is coming as 1. And alpha square is 1 means S plus 3T or alpha is plus minus 1, right? We don't even need to find S and T. We directly get alpha is plus minus 1 and beta is 1, right? So the main idea in the problem is understanding the meaning of linear dependent vectors. If two vectors are linearly dependent, then you can write any one of them as a linear combination of the other two, right? So that is something that you should understand. Let's move on to the next problem. A vector A has components 2p and 1, components 2p and 1 with respect to a rectangular Cartesian system. A rectangular Cartesian system This system is rotated by a certain angle. The system is rotated by a certain angle in the anti-clockwise sense if with respect to the new system, if with respect to the new system, the vector A has components 2 p plus 1 and 1, p plus 1 and 1. Find p. Very simple question. You need to understand that this is my original x and y axis, and there was a vector like this, right? And let's say it has components 2p here and 1 here. These are the two components of the vector in terms of the old axis, right? Now the axis was rotated. This becomes your y dash and x dash. And now the two components are p plus 1 and 1, right? So basically the same vector A was written as some 2p I cap plus 1 j cap, and later it is being written as A vector is p plus 1 in the new axis I dash plus 1 j dash, right? We have to find p. The main thing you have to understand is if you have rotated the axis and not touched the vector at all, the magnitude of the vector cannot change. The length of the vector will remain same even though you are talking about it from two different axes, right? So therefore the magnitude of the vector here root over 4p square plus 1 should be equal to the magnitude of the vector here, which is p plus 1 whole square plus 1. And if you equate the two magnitudes, you would get basically 4p square is equal to p plus 1 whole square. And basically that means 4p is equal to plus minus p plus 1. So that means if you take the positive sign, you get 3p is equal to 1. So p is equal to 1 by 3. And if you take the negative sign, you get minus p minus 1. So you're getting 5p is equal to minus 1 or p is equal to minus 1 by 5, right? As long as I've not made some mistake here. 1 second. Okay, I have made a mistake here. It is 2p. Once I take square roots, it should be 2p is equal to plus minus p plus 1. So I will get 2p is equal to p plus 1, from where I get p is equal to 1. Or I will get 2p is equal to minus p minus 1, from where I get p is equal to minus 1 by 3. So these are the two possible values of p if you have rotated it by a certain angle, right? The main idea to understand here is that even if you rotate, the magnitude of the vector cannot change if you rotate the axis. The components will become different, but the modulus remains same, right? Okay. Question number 6 says a point I is the in center of triangle ABC. Then we have to show that mod of BC, the mod of BC vector multiplied by IA vector. By the way, this is not a dot product because we cannot do a dot product of a scalar and a vector. Plus mod of CA vector multiplied by IB plus mod of AB vector multiplied by IC is equal to 0 vector. Right. So mod of BC, we can say let side lengths BC be equal to A, CA be equal to B, and AB be equal to C. So what I have to show here is that A times IA plus B times IB plus C times IC is equal to 0 vector, right? Okay, so what we can do is let the triangle be something like this, ABC, and let's assume that origin is somewhere here, and the position vectors of OA, OB, and OC. I'll draw a different figure. Let's say origin is here. Position vectors OB, OA, and OC. We can define, let OA be called X, OB be called Y, and OC be called Z. These are the position vectors of the vertices of the triangle. And by the theory that we have learned, the in-center should be opposite side A times position vector of A, so AX, plus opposite side B times position vector of B, so BY, plus CZ by A plus B plus C. This is the position vector of my in-center, and that is a theory that we have discussed before. It comes from angle bisector theorem and section formulas. So you should go through that theory again if you don't remember. We have done it in the previous video. If this is the coordinate of I, now I can easily find what is IA, right? Because OA was equal to what? OA was X. So if I want to find IA, all I have to do is OA minus OI, right? Because we can see clearly from the figure, OA is going to be OI plus IA. So IA vector is what? OA minus OI, right? So here we have to do A times IA. So A times OA minus OI plus B times IB. So OB minus OI plus C times IC. So that is OC minus OI, right? That is what I have to evaluate and show that it is equal to 0 vector. So if you think about it, it becomes AOA plus BOB plus COC minus A plus B plus COI, right? And now we already know what is I. So A plus B plus COI is simply minus AX minus BY minus CZ. And AOA is AX, and this is BY, and this is CZ. So you can see clearly that this cancels and becomes 0 vector. And that is our proof, right? So basically, if you know the position vector of A, B, and C sides, the vertices A, B, and C, the position vectors of those 3 points, if you know in a triangle, let's say they're X, Y, and Z, the in-center's position vector is AX plus BY plus CZ by A plus B plus C, where what is the meaning of small a, small b, small c? Small a is the side opposite to the vertex A, small b is the side opposite to vertex B, and small c is the side opposite to vertex C. So this will help you solve the problem. Here, because we use the result, we were easily able to do the proof here. Okay, fine. So the next question that we'll look at is this one. If S is the circumcenter of triangle ABC and O is the orthocenter, we have to show that, first of all, SA plus SB plus SC is equal to SO. And secondly, we have to show that OA plus OB plus OC is equal to 2 times of OS. Okay, Fine. So let's draw the triangle and try to label the points O and S in it. So this is my A, this is my B, this is my C. For orthocenter, I have to draw altitudes. Let's draw two altitudes. This should be my O, this point, because this is 90 and this is 90. For circumcenter, I have to draw perpendicular bisectors. I will draw again two of them. So these are my perpendicular bisectors. So this becomes my S, right? And this is 90 and this is 90. And obviously this point D is such that BD is equal to DC. And this is my ONS situation, right? Now, what I would do here is connect A to D and connect O to S. And join this also and join this also. So notice first of all that AO is perpendicular to BC and DS is perpendicular to BC. Because AO is part of the orthocenter altitude. So it is perpendicular. If you extend it, this is perpendicular. And therefore we can see that AO is parallel to DS, right? If AO is parallel to DS and this point is labeled as G, we can clearly see that triangle AOG is similar to triangle GSD. Why? Because vertically opposite angles are same and the lines AO and DS are parallel, so interior alternate angles are also same, right? So by AAA similarity, these two are similar. And now what we have to realize is that line AD is a median. Line AD is a median and you should realize that this point G is the centroid of the triangle. Centroid. And this G, if it is the centroid, then it will divide the median in the ratio 2 is to 1. So AG is to GD is equal to 2 is to 1. Right? And if AG is to GD is 2 is to 1, because of similarity, we will also know the ratio of AO and SD. So we know AO by SD is equal to AG by GD is equal to 2 by 1. Right? Now think about it. If that is the case, then we have 2 times SD is equal to AO, right? And therefore, you can say twice of SD vector is equal to AO vector, right? So that is the result that we get from similar triangles here and here, and the fact that G is the centroid, because the line AD was the median, right? Now, let's think of what is SA plus SB plus SC, right? So SA plus SB plus SC. So that can be written as SB at least can be written as SD plus SC, SD plus SB. I will say that again. If this is SA plus SB, think of SB vector, that is SD plus DB. SD plus DB. And what is SC vector? SC vector would be SD plus DC. Now we know that DB and DC are equal distance, but DB vector and DC vector will be equal and opposite to each other. So DB plus DC will get cancelled and will become 0, right? So what we have here is SA plus 2SD, SA plus 2 times SD, right? But 2 times SD we know is AO vector, right? So this is becoming what? This is becoming SA plus AO vector, and SA plus AO will be equal to obviously SO vector, right? So we have proved the first statement because we were able to use the fact that dB vector plus DC vector is 0 and 2 times SD vector is equal to AO vector, which we proved by similarity. And so therefore we are getting this result, SA plus SB plus SC is SO, right? The second part is trying to find out OA plus OB plus OC, right? So let's do that. I will do it here only. I'll just rub off this space. So OA plus OB plus OC, it can be written as OA plus OB vector can be written as OD plus DB. OB vector can be written as OD plus DB, right? That's the same thing. You will see why we are doing that. And similarly, OC vector can be written as OD plus DC. And now we know DB plus DC anyway adds up to 0. So that part is gone. So we have this is equal to OA plus 2 times OD, right? And 2 times OD we have to think of. OD is OS plus SD, right? So we have here, I will rub off the space on top here. I can write OA plus 2 times OD as OA plus 2 times OD can be thought of as OS plus ST, right? So now we have OA plus 2OS plus 2SD, right? Now 2SD is actually going to be equal to AO. We have already seen that before. So therefore you have OA plus AO plus 2OS, and OA plus AO is going to cancel out because they are equal and opposite. So you end up with this is equal to 2 times OS vector. And that is our proof. We have proved the second result also. So a little bit of similar triangles, a little bit of geometry was all that was required to prove this, right? Let's move on to the next problem. In this question, we have if A is equal to 2i minus j plus k, B is equal to I plus 3j minus 2k, and C, okay, there are 4 vectors. C is equal to minus 2i plus j minus 3k, and D is equal to 3i plus 2j minus 5k. Now they are saying if D is equal to P times A plus Q times B plus R times C, show that P, Q, P by 2 and R are in AP. So very simple question. You just combine the information that you have. You will get equations on P, Q and R. So D vector is already given 3i plus 2j minus 5k is equal to P times A. So you have P times 2i minus j plus k plus q times I plus 3j minus 2k and plus r times minus 2i plus j minus 3k. So once you do this addition like this, you are going to get equations. So you'll get 3 is equal to 2p plus q minus 2r. And from here, You also get another equation, 2 is equal to minus p plus 3q plus r, and you also get minus 5 is equal to p minus 2q minus 3r, right? All we have to do is solve these equations and find the values of p, q, and r. When you solve it, you will be able to show that p is 3, q is 1, and r is 2. And then that means that 1, p by 2, 3 by 2, and r2 are in AP. That is clear. So, very simple question. You just have to solve the situation, right? Compare the values of p, q, and r and solve it. Let's move on to the next problem. We have if C is equal to 3a plus 4b and 2c is equal to a minus 3b, then show that C and B have opposite directions, and mod C is greater than twice of mod B. So first of all, from here, if C is equal to 3a plus 4b and 2c is equal to a minus 3b, this is given to us, then we can combine these two equations to eliminate sort of like C, right? Let's think about it. C is 3a plus 4b, and we have 6c is 3a minus 9b, right? So you can eliminate 3a from here by subtracting. You will get 5c is equal to minus 9 minus 4 minus 13b, right? If this is the situation, then automatically it means C is equal to minus 13 by 5 into B, which means C and B are in opposite directions because it is just a multiplication of one vector with a negative scalar. So that means they are anti-parallel or in opposite directions. And also mod C is going to be 13 by 5 times mod B from this equation if you take modulus, which means mod C is greater than 2 times mod B, right? Because 13 by 5 is bigger than 2, right? So pretty easy problem, nothing major here. Okay, let's move on to the next problem, question number 10. It says OACB is a parallelogram. OACB is a parallelogram. If D is the midpoint, if D is the midpoint of OA, prove that BO and CO intersect in the same ratio. Intersect in the same ratio and find this ratio. Okay, so we have a parallelogram OACB. O is here, let's say A is here, C is here, B is here, and D is the midpoint of OA. We have to show that BO and CO. Okay, I have made a mistake here. The question is saying not BO and CO, it is BD and CO. BD and CO. Right. So we have to join this and this. So what this means is let's take O as the origin and this as A vector, and we will say this is B vector, position vector of capital B, and position vector of C would be C vector, I think. Right. But we don't need to create a new variable actually, because this is A vector and this is B vector. Then C will be A plus B vector by parallelogram law. And you can easily say that OD would be A by 2, right? A by 2 vector is OD. And now I need to find the intersection point M of OC and BD. And we will say that suppose M divides CO in the ratio K is to 1, and suppose M divides BD in the ratio L is to 1. So right now we are going to suppose that M divides the two lines OC and BD in different ratio, K and L, right? So the coordinates of M by section formula on the CO line would be OM position vector should be K times O. So this is K and this is 1. K is to 1 ratio. So K times 0 vector plus 1 times A plus B divided by K plus 1. You are getting A plus B vector by K plus 1. That is the position vector of M. And on the other hand, if I say it is L is to 1 here, L is to 1 here, the ratio of BM and MD, so then OM vector is coming out to be L times A by 2 vector, because D vector was A by 2 plus 1 times B vector by L plus 1, right? You are getting LA plus 2B by 2L plus 2, right? And now, since both are representing the same point, we can equate this with this, right? They should be representing the same thing. So therefore, let's do that equality and then we'll get some relations on K and L, right? So we are getting A plus B by K plus 1 is equal to LA plus 2B by 2L plus 2, right? So from here, you'll bring everything to one side, you'll get 2LA plus 2LB plus 2A plus 2B is equal to KLA plus 2KB plus LA plus 2B, right? So we are getting all the A's together, 2L plus 2 minus KL minus L minus KL minus L A plus, so this term is gone, this term is gone, this is gone, this is gone. 2B and 2B anyway are gone, and you get 2L minus 2K B is equal to 0 vector, right? So from here it is obvious that if these things are 0 vector, then L is equal to K, and that proves that they are dividing the two sides are being divided by point m in the same ratio, because L and K are same. And then we can find the value of it by putting it here. We get 2L plus 2 minus L square minus L is equal to 0. So this is L square minus L minus 2 is 0. And that means L is equal to L minus 2, L plus 1 this is. So L is equal to 2 or minus 1, and this is internal division. So we'll say L is equal to 2. And the required ratio is basically 2 is to 1. That is the required ratio, right? Okay. So That finishes off this problem. Now let's look at one last problem, and that will be completing a revision of whatever we have done so far, the vector methods we have learned so far. So the question says, through the midpoint P of side AD in a parallelogram ABCD, straight line BP is drawn, cutting AC at R and CD produced at K. At Q. You have to prove that QR vector is 2 times RB vector. Okay, so we will have a parallelogram ABCD, and through the midpoint P of side AD, this is P, a straight line BP is drawn. Okay, cutting AC at R. Okay, so BP line is drawn like this. It cuts AC at R. This is R, this is P, and it cuts CD produced at Q. This is Q, right? We have to show that the QR vector, the vector from here to here, is equal to twice of RB vector. And we are given that BP is the midpoint of AD, right? So we can take A as the origin. If you take A as the origin and let AB vector be B vector and let AD vector be D vector, then AC, because it's a parallelogram, this will be B plus D. So AC vector would be B plus D, right? And AP vector, so AC vector is B plus D and AP vector would be D by 2, right? Now, we need to find the point of intersection of the line BP and AC. That point is R, right? R is point of intersection of lines BP and AC, right? So what is the vector equation of line BP? Equation of line BP. Notice that we know 2 points on the line, B point and P point. So the vector equation by the 2-point form that we have learned will be 1 minus T into B plus T times P's coordinate. P's coordinate is D by 2, right? So this is the equation of the line BP. Similarly, the equation of line AC. Equation of AC. We know 2 points on it. It will be 1 minus S into A. R vector will be 1 minus S into, but A vector is origin, so 0 vector, plus S into C, which will be B plus D, right? So you're getting R is equal to S into B plus D is my line AC, the diagonal, right? And these two lines must intersect at the point capital R, right? Okay. So actually, before we do that, I will also write the vector equation of the line CD. So think about it, line CD vector equation. So that would be R is equal to, let's use the scalar U now. So 1 minus U D plus U times S B plus D. right? That is the coordinate of C. So here I'm getting D minus UD plus UD plus UB. So this is simply D plus U times B. That is R vector. This is the equation of the line CD, the top side, right? So I know equation of this line, I know equation of this line, and I know equation of this line. So I should be able to just solve the equations now, because if I call this 1, if I call this 2, and if I call this 3, intersection of 2 and 3 will give me R, and intersection of 2 and 1 will give me Q, right? And that's it. That's what I have to do here. So I will just solve it on the next screen. So I have BP equation is R is equal to 1 minus TB plus T times D by 2. Equation of AC line is R is equal to S times B plus T. And equation of CD line is R is equal to D vector plus U times B vector. Here T, S and U are scalars. So now I'm going to solve the equations. I'm going to solve these two first in order to get me the point R. So both have R exists on both the lines. So what I can say is 1 minus T should be S and T by 2 should be S, right? So 1 minus T is equal to T by 2 and you get 1 is equal to 3T by 2. So T is equal to 2 by 3, right? Is equal to S. So my point becomes the R point is going to be 2 by 3 B plus T, right? One second. T is 2 by 3, so S is 1 by 3, right? So R point is what? 1 by 3 B plus T, right? I have solved the two line equations and gotten this. Now I have to intersect the first line with the third line in order to get the point Q, right? So the intersection of these two becomes Q. And how do I do in the intersection? Again, T by 2 is equal to 1 and U is equal to 1 minus T, right? And from these two equations, I'm getting T is equal to 2 and U is equal to minus 1. So I'm getting R is equal to D minus P, right? That is the point for Q. So Q point is basically D minus B position vector. And R point is 1 by 3 B plus T position vector. So let's now try to find our QR vector. QR vector would be position vector of R minus Q. So it is going to be B by 3 plus D by 3 minus D plus B. So it will be 4B by 3 minus 2D by 3, right? That is my QR. And let's find what is RB. RB vector would be B vectors, which will be B minus R vector, which is 1 by 3 B minus 1 by 3 D. So you're getting 2B by 3 minus D by 3. So RB vector is 2B by 3 minus D by 3 and QR vector is 4B by 3 minus 2D by 3. So it is obvious from here that QR is equal to 2 times RB. And that finishes off our proof. Notice that in all of the problems, the geometrical problems that we did, what we did always was choose a good origin and from there start writing the position vectors of the relevant points. And then you have to use section formula, you have to use the line equation through two vectors. If you have two vectors, position vectors, the equation of the line through it would be 1 minus t first position vector plus t times second position vector. So that we have used extensively in all of the questions we have seen so far today, right? Okay. I will stop at this point. The next class will be about dot product of vectors and we'll start our product of vectors discussion. Then wait for the next class. We'll do an extensive discussion on dot product and its applications. And then we'll move on to cross product and triple products, right? So that's it for now. if you like the content, please subscribe to the channel. This vector series I'll be trying to finish in the next 1 or 2 weeks. Vectors plus 3D. So if you want to do your revision properly, go through all of these videos, try to solve all of these questions. That will definitely help you for JEE Advanced. So that's it for now. I'll see you next time.